Good afternoon, everyone. Good afternoon. Hope all is well. So, as always, let's give everybody a chance to get all the way connected, and then we'll get started. All right, looks like we are all good. See, I think last class, oh, don't have my notes up, hold on. All right, I think we started. Okay, yeah, we did summer 5-2 last class, ended here. So we're picking back up in 5-2, right triangle trig. And we're just gonna do some other values. Last class we ended, I think we were looking for C, or we were missing C. This time we're missing B, side B, but still the same directions as the last problem that we left off with. We want to find the value of the 6 trig functions. And they give us C, side C to be 3, and side A to be 1. So we'll use the Pythagorean theorem to find side B. All right, so using the Pythagorean theorem, a squared plus b squared equals c squared. So remember, c has to be on one side by itself. That's your hypotenuse. That's the longest side, the side opposite of 90 degrees. So that's why you have 1 squared plus b squared equal to 3 squared. That will give us 1 plus b squared equal to 9 once we do our squaring. Then we can subtract 1 from both sides. 1's canceled on the left, and that'll be b squared equal to 8. Take the square root of both sides to get the square off of b. So b is equal to the square root of 8. And let me see if I can write that a little better. So I'll break up that square root of 8 because it's not a perfect square into 4 times 2. Take the square root of 4, that is 2, and leave 2 under the radical. So b is going to be 2 square root of 2. All right. And the green right here is just me re-emphasizing that whole thought process of taking the square root of values that are not perfect squares. Here we have 2 perfect squares. Square root of 81 is 9. Square root of 16 is 4. But if I had the square root of 32, that's not a perfect square. So I would break it up into factors and let one factor be a perfect square, and then the other you leave under the radical. So 16 times 2 is 32. Take the square root of 16, that's 4, and then leave 2 under the radical. So it's just re-emphasizing what happened here with the square root of 8. So you really notice not really a part of the problem, actually. All right. So before we go plugging in values for our trig functions, any questions on how we got to B? All right. So now here is our triangle with the measurement of B plugged in. 3 is our hypotenuse. 1 is our side that's opposite theta. And then 2 square root of 2 is our side that's adjacent to theta. And then we'll plug in, remember SOHCAHTOA, sine is going to be opposite over hypotenuse. So that's 1/3. Cosine is adjacent over hypotenuse, 2 square root of 2/3. Tangent would be opposite over adjacent. Let me see what else they're right here. Okay. So everybody done with the black, don't want to scroll up too far. All right, so we need to rationalize our denominator. So we see that opposite over adjacent is 1/2 square root of 2. So rationalize the denominator, you want to get rid of the radical that's in your denominator. So you can multiply that times the square root of 2, square root of 2 times square root of 2 is square root of 4. That's what we did right here. But remember, whatever you do to the bottom, you have to do to the top as well. So you can't just multiply the bottom by the square root of 2 and not do that to the numerator. So that gives us square root of 2/2 square root of 4. Square root of 4 is 2. So on the bottom, we have 2 times 2. And so that'll give us a final answer of square root of 2/4. All right, questions before we go to the next 3? Everybody okay? So when it comes to cosecant, don't forget that's the inverse of sine. So we're going to flip that. That'll be 3/1, which is just 3. Secant is the inverse of cosine. So that'll be 3/2 square root of 2. Once again, we have square root of 2 in our denominator. So we need to rationalize it by multiplying top and bottom by the square root of 2. That'd be 3 square root of 2/2 square root of 4. Square root of 4 is 2, so that's 2 times 2 in your denominator. So 3 square root of 2/4. And then for our last one, cotangent theta, if we flip tangent, that'll be 2 square root of 2/1, which is just 2 square root of 2. So those are our 6 trig functions. Any questions? Any questions? Make sure we're okay. All right. So here we're looking at trig functions of special angles. So we have our 3 special angles that are emphasized: 30 degrees, 45 degrees, and 60 degrees. Notice that I also gave you the radian measure of that. So 30 degrees is pi/6, 45 is pi/4, 60 is pi/3. And once you start making a connection as to how these flow, you look at the unit circle chart. And let's see. Well, yeah, if we were in class, we would do a unit circle chart, quiz or whatever. But I can shoot you guys a copy of the unit circle, I haven't seen it in a while. Knowing the unit circle, or at least knowing how the unit circle flows, will be able to help you with determining, sine of 30 degrees, cosine of 60 degrees, and so on. Let me see, do I have it up here and I can pull it up? Well, I must have it on my other computer. But yep, so sine of 30 degrees is 1/2. Cosine of 30 degrees is square root of 3/2. Tangent of 30 degrees, square root of 3/3. And then over here we have 45 degrees, square root of 2/2 for both sine and cosine. Tangent is going to be 1. And then here we have sine, cosine, and tangent of 60 degrees. And we'll really get into our coordinates and everything. Notice I put a y over here because sine would be y in your coordinates. Sine would be y, cosine is going to be x for us. So it's something to, keep in the back of your head, till we get there. But when we look at our coordinates, because it's going to be set up using your Cartesian coordinate plane, where you're doing XY plane, and all of that will connect for us. Oh, I wrote it down right here. Okay. Let me see if I can find a good copy of the unit circle. So just reference the chart real quick. So here, notice we have 30 degrees, and this is our X. This would be our Y. Like just like any other, time you're graphing the Cartesian coordinate plane using your X and Y. And so the coordinates of 0 degrees, and 2 pi, because remember 2 pi will be at 360 degrees, which is 1 full rotation, is 1, 0. So you go to the right one, but you don't move X or Y. So X is 1, Y is 0. Then here, if you look at the coordinates of 90 degrees, is 0, 1. So you don't move left or right for X. So that's 0, and then you go up 1. And so that's your unit circle, and it's all based on your Cartesian coordinate plane as its foundation. And so 30 degrees is square root of 3/2 and 1/2. 45 degrees, square root of 2/2, square root of 2/2. And then 60 degrees is 1/2 square root of 3/2. So now, if you look at it, and look at it as being just basic, notice there are only 3 options as far as your numbers are concerned. As far as these coordinates, is either 1/2 square root of 3/2 or square root of 2/2. So even when you go over here into our second quadrant, same type of deal. Third quadrant down here, and even fourth quadrant. So if you start to learn your positions and remember your familiar angles, all of these are reference angles to your familiar angles. And notice here, square root of 2, 1/2 square root of 3/2. Then over here is 1/2 square root of 3/2, but we negative. Why? Because we went to the left and then we went up. Basic Cartesian coordinate plane locations. Down here, same type of deal, but both of them are negative down here. Why? Because we're in the third quadrant. And then over here is positive and negative. So I'll send you a copy of the unit circle chart just in case you don't have access to one, but it will be beneficial to you to at least familiarize yourself with the chart, so that when you go and the book asks you for exact values, You're not throwing in decimals because they want these answers. They want these answers. All right. Yeah, and all that scribble right there was just me explaining what I just explained to you guys. So let's go down here. Let's get to our identities. So the first set is the reciprocal identities. So we already talked about before about how sine and cosecant are inverses of each other. Cosine, secant, same, and then tangent and cotangent. So this is their reciprocal or reciprocals of each other. Better than inverses. Let's say reciprocals of each other. In other words, you flip the fraction, you have the other one. So reciprocal is a better term. So they're reciprocals of each other. So that's where these relationships hold. You know, the mathematical way of representing those relationships. All right, so the next set is quotient identities. So we know that cotangent and tangent are reciprocals of each other, so they should be, you know, the fractions flipped. But what we emphasizing here is that tangent is sine over cosine. And so that means cotangent is going to be cosine over sine. All right. All right, so next set of directions, the next exercise says, given that sine theta is 2/5 and cosine theta is square root of 21/5, find the value of each of the remaining trig functions. All right. So in the blue is what we know to be true. We have sine is 2/5, cosine is square root of 25, square root of 21/5. So if that's the case, we can go ahead and find cosecant and secant, because that's just flipping those fractions. So that's what we did right here. And of course, it doesn't matter which order you find your trig functions in. So might as well go to the easiest ones first. So cosecant is going to be 5/2 because all we're doing is flipping the fraction that came from sine. And then secant is going to be 5 over the square root of 21. But then
I got a quick question.
Yes.
When you're talking about quotient identities, why is cot going to be cos over sin and sine versus CSC and sec?
Okay. Well, if we're just talking about looking at tangent and how tangent is set up. So tangent and cotangent are inverses of each other, reciprocals of each other. So that means all you're doing is flipping the fraction. So cotangent isn't necessarily connected to secant and cosecant. It's more so connected to tangent. And so whatever tangent is, you flip tangent, and then that will be your cotangent.
Okay, thank you.
Yeah, now I've always talked about them together because they're inverses of the first three, but they're not connected. So good question. Good question. All right. So before we go to tangent, any other questions? So that's cosecant and secant. All right. So tangent is cosine, not cosine, but sine over cosine. Hold on 1 second. Sorry about that. So tangent is sine over cosine. So we put sine over cosine as a fraction. And then here with the green line, just emphasizing that division bar represents the division of sine. So we have 2 over 5 divided by the square root of 21 over 5. And whenever divided by a fraction, it means we're going to multiply by the reciprocal. So that's what I did here. Just giving you, the walkthrough of what we're doing. And so I have 2 over the square root of 21. And to rationalize that, multiply top and bottom by the square root of 21. And that would be 2 square root of 21 over 21. All right. So that's tangent. Now to find cotangent, we can flip this fraction, or we can flip this one right here. It's the same fraction. Remember, the only difference is we just wrote it with the square root of 21 times the square root of 21. But before we rationalize it, we could flip that one. And that will take us here. Either way, whenever you do it, it's going to still give you the same answer. This one, you just have to rationalize it again if you were to flip this one. Any questions? Very good. Am I still holding on to the red? Are we all right? All right. So we have 3 more identities, Pythagorean identity. And I put an asterisk beside that sine squared theta plus cosine squared theta equal to 1 because that one always found a way to show up. So even if you don't remember the other two, always try to hold on to this one because that always finds a way to show up somewhere. But the other ones do too. So, make sure you know how to use them. 1 plus tangent. Try to write these ones in such a way that they're definitively ones. But 1 plus tangent squared is equal to secant squared, and then 1 plus cotangent squared is equal to cosecant squared. All right. So here, given that sine theta is 3/5, And theta is an acute angle. Find cosine theta using a trig identity. All right, so in that in the red, they're giving us a hint as to what sign our result should be. Because remember when I showed you the unit circle, if it's in the first quadrant, sine and cosine are positive. If it's in the second quadrant, cosine is negative, but sine is positive. And, each quadrant have a different set of signs. So when they tell you that sine is positive and then theta is an acute angle, they're letting you know that we're in the first quadrant. And so that's just a little diagram of that. And that means that cosine is going to be positive because you're looking for cosine. So it lets us know that cosine is going to be positive. In the purple, that was just emphasizing you can write sine squared one or two ways, either sine squared theta or sine theta squared. Both of those mean the same thing. Okay, before we have to figure this thing out. All right, so we can go ahead and plug those into that first Pythagorean identity. Sine squared plus cosine squared equal to 1. So sine is 3/5. So it'd be 3/5 squared and plus cosine squared equal to 1. So that would leave us with 9/25 plus cosine squared equal to 1. Now to solve for cosine, we can subtract 9/25 from both sides. And then don't forget, whenever you subtract in fractions, you need to make sure you have your common denominator, and then 1 with 25 as the denominator will turn to 25/25. So 25 minus 9 is 16. So we're looking at cosine squared theta equals 16/25. Take the square root of both sides. Don't forget the square root property. And that's why that first statement that they gave us telling us what sine was and what type of angle we had was important, because here we have the option. Oh, I still have my eraser on. Here we have the option of plus and minus. But we've already established that cosine is supposed to be positive, and that's why I was emphasizing here with the red. Theta is acute and theta is in quadrant 1. So that means cosine is going to be positive 4/5. Questions. All right, can you scroll up? All right. So here we have cofunction identities. So when you're dealing with your cofunctions, sine theta is equal to cosine of 90 degrees minus theta. Cosine is equal to sine of 90 degrees minus theta. And then you see tangent and cotangent are related in the same way, and then secant and cosecant are related to each other in the same way when it comes to cofunctions. Also, you see the statement over here. If theta is in radians, then you replace 90 degrees with pi over 2. All right, so next one, find a cofunction with the same value as the given. All right, so the first one is sine 72 degrees. So all you would do is do 90 minus 72, which is 18. So cosine of 18 would be equal to sine of 72. That's the cofunction of sine of 72, cosine of 18. For cosecant, you use secant, but since this is radians, we have pi over 3. That means we need to do pi over 2 minus pi over 3. And once again, since we have fractions, they are going to want the exact answer. So the common denominator of 6, multiply the first fraction by 3, top and bottom, second fraction by 2, top and bottom. And so that would be secant of pi over 6. Any questions? Any questions? Problems with cofunctions. All right, can I scroll up and the rest of the copy? All right, so let's look at some applications. I know you guys couldn't wait to get to some word problems. Let's see. So first thing, you want to look at a few terms like angle of elevation. So an angle formed by a horizontal line. You can write that a little better. And the line of sight to an object that is above the horizontal line. So here's an example of that. So you think about elevating. So your angle is going to go up, horizontal line, angle going up. Of course, if I scroll up and you're still copying something, let me know. Then your angle of depression is an angle formed by a horizontal line and the line of sight to an object that is below the horizontal line. Go ahead and write that out. All right. Yep, it should be the beginning of an example. I don't know why I wrote it so close. All right, so sighting the top of a building, a surveyor measured the angle of elevation to be 20 degrees. The transit is 5 feet above the ground and 300 feet from the building. Find the building's height. So I'll give you a chance to write that down for those who are writing it.
I'm so sorry.
Yep, not a problem. Not a problem at all. So here's my rough sketch of what is going on in this thing. So let's look at it again. Sighting the top of a building. A surveyor measured the angle of elevation. So this is 22 degrees right here. Angle of elevation, 22 degrees. The transit is 5 feet above the ground. So that's what I tried to simulate right here. You know, his machinery that you're looking at to use to view all the stuff is standing 5 feet above the ground. That's my little guy right here. And his transit. And it's 300 feet away from the building. And so that's your line of sight, trying to remove all my scratch work. All right, so they asked us to find the height of the building, so I'm calling the height H. And also I just called. So I'm gonna call this right here. Oh man, still got my voice on. I'm gonna call this right here from the top of the building to the line of sight of the transit A. And we'll come back to the H in a second, but remember, you know, this right here doesn't go all the way to the ground. So that's not your full height. So we're missing 5 feet on that. So I'm going to use tangent because tangent is opposite over adjacent. Opposite of my 22-degree angle is A. And of course, adjacent to it is the 300 feet. So that's how we got this set up right here. Tangent of 22 degrees is equal to A over 300. So before we go any further, is everybody okay with what I've done? We have 22 degrees as our angle of elevation. Opposite of that is A, then adjacent to that is 300 feet. That's how many feet the person is from the building with that transit. All right. So now we can solve for A by multiplying both sides by 300. A will be equal to 310 of 22 degrees, and that will be approximately 121 feet. And Math Lab will let you know, if they want you to round it to the nearest whole number or tenth or whatever the case may be. Evidently in this problem, looking in the book and doing the exercises, telling me to round to the nearest whole number. So we have 121. All right. And then to find the full height, you add 5, because remember it was 5 feet. The line of sight was 5 feet from the ground. All right, questions? Questions on what we did there? Let's go up. Oh, that's it. Okay, they must have only talked about angle of elevation and okay, depression. So I must have ran out of time last time I did that. So if you come across a problem, if you have any questions about it, always feel free to bring it to class. The problems that I have for you are probably just dealing around angle of elevation and angle of depression. So it'll be this type of setup. So try it out and see if you have any questions on those. Let's see, it's 2:17. So a little time. Yep, hand up.
Yeah, I just wanted to know like what you put in the calculator to get 121 feet.
Now if you have, it depends on the type of calculator you have and how you would set it up. Now you do want to make sure that your calculator is in degrees. Now some calculators you will put in 22 first, then hit the tan button, and then multiply it times 300. So what we can do is maybe one day, whether it be after class, or we maybe need to set up a separate Zoom session. You can bring your calculator, show your screen so I can see what type of calculator you have, and then help you out with that. Other calculators, you can put it in just like that, and hit enter, and it will be that way. So it just depends on the type of calculator that you have.
Okay, yeah, I figured it out. It just wasn't in degrees.
Gotcha. Okay, cool. All right, another hand.
I was just wondering where that other number came from, like when you did tangent of 22 degrees equals a over 300 times, is that 380 or is that 300?
Let me make sure. Are you talking about right here?
No, the one above that.
Right here?
Like, what did you times it by?
Okay, so here is where we got our setup. And so that 300 and all of the numbers though came from, just places in the problem. And so it was 300 feet away from the ground. The man is right here. He's 300 feet away from the ground. So that's why that's there. And then we got the relationship of tangent theta is equal to opposite over adjacent. So the side that's opposite of your angle is going to be the number on top. And then the number that's beside your angle will be the number on bottom. And so that's why we have a over 300. And then to solve for a, because we want to know the height, the whole height of the building, but this gives us a piece of that height. So to solve for a and at least get a, we need to multiply both sides by this 300 to get it from under the a. And so that's why that cancels out right here. And that leaves us with 300 times tangent of 22 degrees.
All right.
So did I answer your question? Is that good?
Yeah, I did.
Okay. Anybody else? Anybody else? Make sure you do it. Let's do at least one problem here, and then I'll let you guys go for today. And then, next class we start off with the signs. Okay. Matter of fact, let me see how long this is. Yeah, that'd be a good place to start. All right, so So 5.3 trig functions of any angle. Last section we talked about, special angles. But here we're going to look at trig functions of any angle. Same relationship, just that we're going to use it for unfamiliar angles as well. So we're going to let theta be any angle in standard position. P is going to be a point on the terminal side. So we're talking about right here. Point on the terminal side. And R is going to be the distance formula. So R is equal to the square root of x squared plus y squared. That's the difference from the origin to xy, that point. So this is leaning on what I introduced to you last section, where I said sine is going to be y, cosine is x. So we're doing y over r, cosine is x over r. Tangent, remember tangent was sine over cosine, so y over x, still going to be the same type of relationship. And then all the other three functions will be the reciprocal of those. Mhm. All right, we'll try this out. All right, so we'll let that point P be -3, -5 on that terminal side of theta. And they ask us to find each trig function. So we need X, Y, and R in order to use the relationships that were just introduced here. This is just, me doing a rough sketch of what our angle would be and where it would be located. Notice it would be located in the third quadrant because of our ordered pair. Both values are negative. Remember, our standard position is the origin, our vertex being the origin. You start at the horizontal axis. Axis and going counterclockwise. Positive angle. All right, so -3 squared plus 5 squared would be 9 plus 25, and that's 34. That's square root of 34, R is equal to square root of 34. All right, any problems before we go to our trig functions? All right, so we can go ahead and find each one of our trig functions according to the relationship that we just finished talking about. So sine is y over r. Y is -5. And then r square root of 34. Don't forget to rationalize your denominator. So that'd be -5 square root of 34 over 34. Do the same thing for cosine. It's x over r. That'd be -3 over the square root of 34. Rationalize your denominator is -3 square root of 34 over 34. Tangent is y over x, so it's -5 over -3, which would be 5 over 3.
Somebody's hand is up.
Oh, thank you, sir. Appreciate it. What you got? Somebody had a hand up? Ms. Madison, or was that from the last time you had your hand up?
I think that was from last time.
Okay, okay, cool. Thank you. All right. Almost finished. Cosecant, you're talking about flipping sine or r over y. So that's square root of 34 over -5, which is normally you bring your negative up top or out front. So that'd be negative square root of 34 over 5. secant. Square root of 34 over -3, so it's -34. Square root of 34 over 3. And then cotangent, -3 over -5, which is positive 3/5. Questions, questions, questions. Everybody good, everybody straight. All right, let's see. I think this is a good place to pause without getting too deep in 5.3. All right, so we'll pause right here. We'll pick up at signs of our trig functions and further solidify that. Before we close out, questions, concerns, comments? Is everybody good? Everybody's in math lab? Getting rolling? Anybody see anything? Okay. All right. So at this point, we've done 5.1 and 5.2, and we're in 5.3. So make sure you're trying out the stuff in 5.1, 5.2, see if any questions are popping up or generated. If there are some things that pop up, always feel free to bring them to my attention so we can address. If we go into the weekend and you have a question, I can always make a video. I've done it before, small video, shoot it out to you, or if it's a real good question, shoot out to everybody so everybody can benefit from it. So you don't have to wait until class if a question were to pop up over the weekend or something like that. So if you guys are good, I'm good. Like I said, I don't want to go too far and then have to stop in a place that's not really a good place to stop. So that was a good place to stop. So I will see you guys on next class. We'll look to close out 5.3. All right. You guys take care. Thank you.
Have a good day. Thank you.
Same. Take care.
Have a good day.
Thanks, you the same. Take care.
Bye.
Thank you very much.
All right. Take care. Bye.